Alright, solving. So when solving an equation that looks like this, where the x term is missing, we have an x squared term, but there's no x term in this quadratic, we just solve like a regular equation. Remember, when solving an equation, what we do is we work PEMDAS backwards. So first we start by undoing any adding and subtracting. So we're going to undo subtract 25 with add 25. And what you do to one side, you do the same thing to the other side. This gives us negative 3x squared. This cancels out, equals 30. And now that I think about it, I'm going to change the problem to positive 3 just to make it work out. PEMDAS backwards, the next thing we would undo is any multiplying or dividing. So the 3 is multiplied times the x squared, so we're going to divide by 3. 3 divided by 3 is 1, so we get 1x squared equals 30 divided by 3 is, right, 10. Okay, and now the next thing we want to undo in PEMDAS is exponents. So to undo a square, we take the square root, and what you do to one side, you do to the other side. Then the square and the square root, they cancel out, leaving us with x equals the square root of 10. Well, when you simplify that, or try to, you'll notice there aren't any perfect squares that go into 10. 4 does not go into 10. 9 does not go into 10, and that's the only two we can try because the next one is 16, and obviously 16 won't go into 10. So our answer is just going to be plus or minus the square root of 10. Now, as a little bonus, simplifying radicals, let's say that we have the square root of 28. And we want to simplify that. This is a separate problem. We would check our perfect squares. 4 goes into 28. Keep checking. 9 does not. 16 does not. 25 does not. So at this point, the next one is 36, and that obviously won't go into 28. So 4. So that breaks down to the square root of 4, and 4 times what is 28? That's right, 7. So the square root of 4 is 2. The square root of 7, we can't take that, and none of these perfect squares go into 7 evenly. So we just write it down. Don't forget your plus and minus. Bonus.